To gaze upon the masterful beauty of a pristine forest at dawn, or the delicately intricate wings of a butterfly, one might surmise that nature at heart is an artist. Though, as most people already know, there exists in the natural world a detailed sense of numerical order that bears the mark of a true mathematician, yet often it seems you have to be one to fully appreciate its complexity. But you don't. The universe may be chaotic and unpredictable, but it's also a highly organized physical realm bound by the laws of mathematics. One of the most fundamental and strikingly beautiful ways these laws manifest is through the golden ratio. It's not hard to find examples of this logarithmic phenomenon in nature, whether it's a simple houseplant like this aloe, or an expansive spiral galaxy like the spiral galaxy Messier 81. This one, they all originate from the same mathematical concepts. The golden ratio, often represented by the Greek letter phi, is directly tied to a numerical pattern known as the Fibonacci Sequence, which is a list composed of numbers that are the sum of the previous two numbers in the sequence. Often referred to as the natural numbering system of the cosmos, the Fibonacci sequence starts out simply. 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. But before long you'll find yourself adding up numbers in the thousands and millions, and it just keeps going on forever like that. When a Fibonacci number is divided by the Fibonacci number that came before it, it approaches the golden ratio, which is an irrational number that starts out as 1.618033987 and once again goes on forever. Leonardo Pisano, known as Fibonacci, identified this series for the first time in 1202 to solve a practical problem. How many pairs of rabbits are obtained in a year from a single pair, assuming that it produces every month, except the first, a new couple that in turn becomes fertile starting from the second month? The answer is 144 pairs of rabbits. In this series, each number is the result of the sum of the two previous ones, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, up to infinity. Examples of approximate golden spirals can be found throughout nature, most prominently in seashells, ocean waves, spiderwebs, and even chameleon tails. Shape, form, and ratio create beauty and strength in the world around us. It is no surprise that the origin of geometry springs forth from the laws of the physical nature of the universe and is embodied in the environment all around us. Sacred geometry charts the unfolding of number in space. It differs from mundane geometry purely in the sense that the moves and concepts involved are regarded as having symbolic value, and thus, like good music, facilitate the evolution of the soul. The way that certain shapes fit together like platonic solids seem to evoke feelings of resonance with the universe. Mathematics is the alphabet in which God wrote the universe. Natural philosophy is written in this great book that is continually open before our eyes. I say the universe, but it cannot be understood unless you first learn to understand the language and know the characters in which it is written. He is written in mathematical language, and the characters are triangles, circles, and other geometric figures, without which means it is impossible to humanly understand a word of them. Without these, it is a vain wandering through a dark labyrinth. Galileo Galilei. No importance was attached to this sequence until the 19th century, when it was discovered that it can be applied, for example, in the calculation of probabilities, in the golden ratio, and in the golden triangle. Fibonacci numbers are plentifully found in nature. The petals of many flowers are Fibonacci numbers, such as sunflowers. In fact, the small flowers in the center of the sunflower, which is actually an inflorescence, are arranged along two sets of spirals which turn clockwise and counterclockwise. The pistils on the flower corollas often arrange themselves according to a precise pattern formed by spirals whose numbers correspond to one of the Fibonacci series. There are usually 34 spirals oriented clockwise, while those oriented counterclockwise 55, 2 Fibonacci numbers. At other times they are respectively 55 and 89 or 89 and 144. These are always consecutive Fibonacci numbers. Fibonacci numbers are also present in the number of inflorescences of vegetables such as Romanesco broccoli. This vegetable is one of the most remarkable foods in the world. It's just so beautiful. Look at it. So fractally and beautiful. I love my Romanesco. The relationship between the lengths of the phalanges of the middle and ring fingers of an adult human is golden, as is the relationship between the length of the arm and the forearm, and between the length of the leg and its lower part. This logarithmic spiral depicts growth and expansion in the universe. Fractals and spirals reveal an underlying order within many structures that on the surface may seem chaotic. The golden ratio is the dividing point of a segment in such a way that the ratio between the two parts, the smallest to the largest, is equal to the ratio of the largest part to the whole segment. This ratio is an irrational number whose marvelous mathematical properties were known from the most extreme antiquity, as it indicates a development of constant growth expressed with a spiral that develops infinitely. It was considered the seal of the creative principle, which is observed reproduced infinite times in nature, from the arrangement of buds and seeds in plants, to the spiral of the shells of the mollusks, to the conformation of crystals, and was revered as a direct expression of divine power. Most of the sacred buildings somehow exhibit the golden ratio in their proportions. The golden proportion was widely used by the ancient Greeks as a harmonic relationship in architectural constructions. We find them in the Egyptian pyramids and in the Parthenon, in the Athenian Acropolis, and in sculptural representations. The golden ratio was also widely taken up in the Renaissance. The dimensions of the Mona Lisa by Leonardo da Vinci are in the golden ratio. And still up to the present day, in modern architecture, the United Nations headquarters has golden proportions. The Fibonacci sequence is also abundantly represented in music, for example, in Johann Sebastian Bach's fugues, in Mozart's sonatas, in Beethoven's Fifth Symphony, in Schubert's sonata, in A, D. The golden ratio is an allegory of the relationship between macrocosm and microcosm, between God and man, the universe and nature, a relationship between the whole and the part that was endlessly repeated between the same largest and smallest part, and so on, through further subdivisions. Over time, various philosophers and artists have come to grasp an ideal of beauty and harmony, pushing themselves to search for it, and in some cases to recreate it in the anthropic environment as a canon of beauty. Evidence of this is the history of the name, which in more recent times has taken on the names of Oreo, or golden, or divine. Historically, there are several open questions regarding whether and which people, before the Greeks, knew the golden section and consciously used it in their works. The most important cases are those related to the Babylonians and the Egyptians. The Vitruvian Man, Study of Proportionality of a Human Body, by Leonardo da Vinci, circa 1500, inscribed in a square and in a circle, reveals the existence of mathematical relationships in the proportions of the human body, and therefore a symbol of the correspondence between macrocosm and microcosm. In it, the ratio of the side of the square to the radius of the circle is golden. Very often it happens that in the works of different artists, a The presence of the golden section is found especially in the form of a golden rectangle. For example, in Greek architecture, in the construction of medieval churches, in Renaissance paintings. Vitruvius, a Roman architect of the 1st century BC, had already studied what the ideal proportions of an aesthetic canon should be, noting, for example, that the height of a human figure must have been equal to the opening of his arms, and that the same figure could be inscribed in a circle. Several artists tried their hand at the reproduction of the ideal man outlined by Vitruvius up to Leonardo. Now we can draw the golden spiral. Let's draw it on graph paper. And now let's try it with a compass and ruler. November 23, 1123, is Fibonacci Day, a special day in honor of the European mathematician who discovered a numerical sequence that manifests itself rather spectacularly all throughout nature. As far as dates go, 1123 happens to be of particular significance to mathematicians and number nerds. It is widely recognized as Fibonacci Day because the numbers on the date match the first 4 numbers in the famed Fibonacci sequence. More than just giving math whizzes another odd holiday, though, Fibonacci Day serves an important purpose: to celebrate the inherent beauty of mathematics and how we can observe it. Check out the spiral shape of a nautilus shell. Here's a tidal wave. Take a look at these flowers too. It's in this hurricane as well. Take a look at the way a tree's branches grow. And hey, Halloween's coming, so you can express your love of math and nature. Let it show and let it glow. Grab a pumpkin, and don't worry if you're not a very experienced pumpkin carver. Neither am I, but I'm learning to love it. So grab your pumpkin, cut the top, scoop out the guts, and save some for later so you can make a DIY beauty mask and your carving kit. Although you can do fine with a knife like this and a small tool like this. Sketch on your design and carve on. And enjoy! Today, take the time to appreciate the beauty around you and trust the flow, my friend.